Hello, everyone, and welcome to the Argo CD and Rollouts community meeting. My name is Jesse Soon, and I'm a software engineer on the Argo project. And so today we have a couple agenda items. We have Leonardo, who will be discussing um, how to run Argo CD in an air-gapped environment. And then Alex will be giving an update or a presentation about the Argo CD, which is a tool that lets you update Argo CD based on Docker pushes. Uh, and then finally, I'll give a quick um, uh, overview of what's happening in Argo rollouts and our plan to go to 1.0 in the next release. So with that, Leonardo, are you ready to share?
Yeah, I'm good. And you can call me Leo. Don't worry about it. Everybody does. Okay, so I'm gonna share real quick. Can you see my screen?
Yes, I can.
Okay. All right. So we've been using Argo. Well, a little bit about myself first. My name is Leonardo Murillo. You can call me Leo. I'm founder of a consulting firm called Cloud Native Architects, and I'm CTO at Quinix. I'm a DevOps Institute ambassador, and I organize the CNCF community chapter for Costa Rica. So I'd love to kind of keep talking about this and connect. You have my details on the screen, so I'd love like look me up on LinkedIn or Twitter, and I blog about this type of thing, right? So you can also kind of like see my blog at morillodigital.com. So what I wanted to show you all today is basically how we approach this challenge, right? So one of our clients, and I'll talk a little bit about the client soon, came to us with a challenge of basically deploying Argo CD on a fully air-gapped cluster that has no existing container image registry. There's no Git repository. There is nothing except for a bare bones Kubernetes cluster. Everything had to be automated. And since it was going to be deployed across numerous different clusters that were air-gapped, we really couldn't use anything that would be dynamically allocated, right? So no ports or anything like that, we just couldn't use. It had to be no ingresses, nothing that was host name based or with a host name that would be resolvable at the node level. So that was kind of like the challenge that we were approached with. And our client is a 5G network function provider. So what they do is they build network functions for 5G, and they have to, of course, deploy these to the mostly bare metal clusters where there are different network functions that are running, right? So these are very, very much controlled environments, tightly secured. That was the challenge. Um, so let me kind of like walk you through what we built. It was the first thing that we realized is it was going to be kind of like a complex process, right? Chicken and egg sort of situation. What goes in first, and how do we put it in place? So we actually wrote a tool for installing an air-gapped setup of Argo that basically automates the whole process that I'm going to be walking you through. Okay, we wrote it in Go, and basically let me show you kind of how we approached it. And I'm very curious. Because this is, after all, an opinionated way of doing it. I'd love to hear what others in the community have to say, so please do reach out. Um, the first thing that we do is we create an installation bundle. The installation bundle basically has the Git repo, the full Git repo, and since we cannot reach out for any Helm registry or any other repository, basically take the community charts as they are, we just stick them in the repo right there. We also include a directory with all the compressed Docker images that all those Helm charts are going to use, right? We automated that process. We basically walk through the Helm charts and look up all the references. We build them and we tag them with the internal service name of the registry we're going to be deploying. So I'll show that shortly, right? So we basically walk the Helm charts, pull all the images, save them, tag them, and save them, right? An additional image that we're also putting in that bundle is a very minimalistic, just the bare bones Docker registry image, right? Because we're going to need a Docker registry to push those images into, right? And of course, the custom tool that we built to automate this whole process. So we put that in a package and we hand it over to the operator that's going to install it. Now, the first thing that the tool does is it selects a node by label. This is something that we request the cluster operator to do ahead of time. We will not need access to all the nodes, and we really don't expect to be pushing images to all the nodes to basically bootstrap the solution. So we asked them, we just need access to one node and just give it a label. And what we do is, once we have identified that node, we basically push the Docker image directly to the daemon running on that node, right? That means that we have the registry image available for installation. The installer pushes it right into the node. Once the node has the image already, then we apply a deployment, because basically we need two types of access, right? We need access to the node itself via SSH to be able to push the image, and we need CTL access, kube control access, so that we can actually apply a Helm chart. The Helm chart is, or a manifest in this case. This manifest is basically creating a service and spinning up a deployment that is using node affinity to make sure that it's running on that specific node where we have the label, where we pushed the image. And we give it an internal, kind of like just a good old Kubernetes internal resolvable only service name, right? So at this point, we have the Docker image in the node, we have a service, a deployment, and a pod running with our Docker image that it didn't have to get pulled because it was already in the node. But this is still not enough, right? Because registry.platform or .namespace.service.cluster.local is not going to be resolvable outside of the cluster, right? And when our kubelet asks the container runtime to kind of like fetch an image or run an image, it's going to try and find it in some registry that it can resolve, right? So we have our registry. And the next thing that we do is we use this tool called kube forward. So kube forward basically exposes the services in the cluster to the node. Now it does that kind of like in a relatively hacky way. You have to expose the, well, first of all, we run it as a daemon set, right? So that there is a kube forward container running on every node in the cluster. And we expose the service to the node using kube forward. And kube forward has this little hack that it basically creates an etc hosts entry for every service that it's exposing at the node level, right? So once we have done that, we actually can resolve the container runtime at the node level, can resolve the host name of the registry running inside the cluster. So if you basically do pull of an image at node level, you can fetch it from the container registry running in the cluster using the registry, the container, the cluster internal service name. Okay. So at this point, we are able to basically fetch images, to pull images from the registry at the node level. Once we have that, then we take all the images that were in the bundle and we push them to the registry, which means now we have a registry platform service cluster local Docker registry with all the images that all our Helm charts are going to need available in all the nodes of the cluster, right? Because we're running this daemon set that will route traffic to the registry inside the cluster. Now, I did mention that this is a bit of a, like if you think about it in terms of security, right? Host network, true, like host network access and kind of like etc hosts manipulation. These are basically um, permissions that we granted ourselves in designing this because it was a highly secured air gapped environment. Like this is probably not something that we would have done anywhere else, right? So we have all the images. We created a seed chart. This seed chart basically does all sorts of things that you need to kind of like seed the cluster to be able to have Argo have access to some repo that will be used for syncing the cluster with kind of like whatever is in the repo, right? So this C chart is doing a bunch of things. We're using Kubernetes secret generator to generate a set of credentials for Git, and we're deploying Git, which is basically a Git repo inside the cluster. We also automatically generate using Kubernetes secret generator a set of credentials for Argo and an SSH key pair for Git, right? The whole idea here is that Argo is going to be syncing against the repository running in the cluster. That repository is stored in Git, and it will need to authenticate against that Git. So we create a key pair using secret generator so that Argo can talk to Git. And then there's a job that uses the credentials that were dynamically generated to create a Git API token. With that API token, we attach the SSH key that we also created to Git, and we create the first repository, which is going to be empty at this point inside Git, right? That is the repository that Argo is going to start tracking. And then all we have to do is basically push the repo that we have in our installing bundle to that Git repository. At that point, through automation, Argo is already tracking the repository. It has basically an application set up to track that repository. So we just push it in, and at that point in time, Argo takes over. And what we do is when we push the cluster, when we push our repo, which is copied into our bundle, to the cluster, and we have an application pointing to the repository that has a whole bunch of other Helm charts. Every other application that we need pointing to every one of the Helm charts that are community Helm charts in the repo. All of those charts and all of those images are um, basically by means of value overrides pointed to the cluster resources, right? We have a Docker registry running in the cluster. We have a Git running in the cluster. So every Helm chart that we install is basically a path in the Git repo inside the cluster. Every Docker image in those Helm charts is a Docker image in the registry running in the cluster, right? Um, we basically bootstrap. We're using the Argo Helm to deploy Argo. So when we deploy Argo, we say, all right, you're going to use the Git service that is running in the cluster, and you're going to install the following additional applications, which are basic. We're kind of like following the apps in apps uh, pattern, right? So in this path, we platform core, we have all the other applications which are basically sourced from Helm charts that are also in the repo to install. There's really nothing much in platform core. There's just our different applications of all the different components that Argo is installing for us by tracking this repo. We install a drone and cert manager and all this stuff, right? Um, and the only thing that we make sure is that we are basically using value overrides for everything that we are installing, right? Because we're going to have to point all those things to the in cluster resources, and we don't want to. And we're using this not just for air-gapped environments. This is also used in kind of like internet reachable, internet available environments. And that's it. We have Argo tracking in cluster repository, fetching in cluster images, and basically syncing the cluster against the in cluster repo. So at that point, the question is kind of like how do updates happen? It becomes very simple, right? When we produce a new bundle, we basically just create a new installation bundle where we have all the updated images, and we have the latest copy of the repo, right? Or wherever we kind of like froze it, right? Or where we decided to release it. So the binary, the Go binary, the little installation tool that we wrote, uh, checks the in cluster registry Docker image versions against the new versions that are bundled in the installer, updates, basically pushes any new Docker image to the in cluster Docker registry as needed, and then it just pushes the repo, right? Which basically just fast forwards the repo to whichever new state, and Argo takes it from there, and the cluster gets updated, and that's basically it. Thank you. That's how we did it. Um, I just want to give a shout out to a colleague of mine, Joseph. If he sees this recording, he was also very much involved in getting this thing set up, and reach out to me. And I'd love to hear kind of like questions or comments of anybody that's curious. And thank you, Jesse, for letting me show this around.
Oh no, thank you. That was uh, quite impressive. I was just curious. What are some of the use cases for the air gapped environments? I know you're probably doing a lot of consulting, but just curious, like what
Well,
things.
the one use case that this was sourced on was the 5G network functions, right? These are clusters that are likely running on a far edge, or on kind of like mid edge, running on bare metal. They have, and there was, it's even something that we've used not just for fully air gap, because some of these clusters really have no internet connectivity at all, and there's nothing else other than the cluster and the need to run the network functions, right? But we also found that there's some of these clusters that are on very limited bandwidth, so pulling images from public registries and kind of like doing anything as such is complicated. They're also heavily audited. So this installing bundle that we hand out is usually very much inspected, uh, and there's also a need to make sure that we are not fetching, because of security and governance, and kind of like supply chain control, not fetching community images right off the community's repos, rather making sure that we've gotten them. Matter of fact is a lot of these images are actually just community Docker images that we pull and we rebuild and we sign, so that we can basically guarantee that we have some level of control as to what's going in there, right?
Right.
Does that answer your question?
Yeah, yeah, it does.
I'm kind of curious about the 5G use case where you're presumably providing internet connectivity, but then the hardware itself is somehow air gapped. Like, wouldn't it need to be connected in some way to what's providing the downstream internet?
That's a very good question, and that's something that I would ask the guys running these clusters. But the whole point is the cluster is completely completely air gap, and I wonder how they're doing it, because I mean I think there is not necessarily an overlap in terms of internet access to cluster operation, right? You could effectively be, uh, I don't know, encapsulating and passing over to, like, you know what I'm saying? You could have no internet access. You could just have an uplink to some other place where there is internet access, and you're encapsulating traffic, and you don't want to use the same pipes, or you're encapsulating, I think there's any numerous reasons. I don't know, uh, but the point is it would have been a whole lot simpler if there were internet access. I should have asked them in the first place. But the point is that it doesn't, that there isn't
Yeah,
any
wow,
way
that's
to.
amazing. How much space roughly does one of those bundles take up? Is this like a 16 gig drive or is this much bigger?
It does fit in the 16 gig drive, but it is bigger than I would anticipate, that I would want. For example, Harbor is huge. There's a whole bunch of images that go into Harbor. There's Argo, is we're using not just Argo CD, but we're using also rollouts and workflow and events. So that's kind of like also taking up space. I think it does fit in a 16 gig drive. It's also kind of like small enough, quote unquote, to be able to kind of like put on an SFTP for them to fetch from somewhere, right?
Yeah.
But it is non. It's not little. You know what I'm saying? It's in the tens of gigabytes total space.
Did you have to fix anything upstream for any projects that had some, uh, dependencies on the internet, like CDNs and stuff? I know Argo CD had that dependency and it got removed, but
There's one thing that I actually just got merged in today, for Argo Helm.
mm,
So one of the things that we actually do in some use cases is we actually have to spin up ingresses.
mm,
And we have to give those ingresses as, of course, a kind of like a TLS certificate, right? That they have to be, they have to have a certificate, and you cannot reach, let's encrypt. There's no certification authority. So what we did was use a CA, cluster issuer, like a certificate authority cluster issuer for, and we actually generate a CA certificate for each cluster, also kind of like with this secret manager sort of thing, right? We generate a CA certificate for the cluster. We put it in the secret, and then we use that CA certificate and the cert manager CA cluster issuer to generate certificates for the ingresses. And we kind of like had a problem where, of course, for the CA certificate that you're creating that is using to sign the certificates that are used in ingresses to be trusted by anything that is consuming those endpoints, that has to be a trusted certificate, right? It's got to be in the trusted certificate key store or whatever you call it. And that either man, and you cannot kind of like insert that in the image at build time because it's going to be dynamically generated for every cluster, right? So you actually would want to just stick it into the runtime cluster, right? But that means you actually kind of had to put it in the ephemeral storage of the image, and then do kind of like your whatever CA cluster, I mean CA root update or whatever the name is, right? And we just couldn't do it with the Argo implementation as it's in the Argo Helm. We could have done it with lifecycle hooks, like if we do a post start, but the Argo Helm actually didn't have that support. I just got that tiny little PR merged in today so that we could actually. Because what we ended up doing is just wiping off the previous root certificates that were in there and just adding the root certificate because after all, there's not going to be any talking to anything else, right? So we could just say, hey, you trust this one root certificate, period. But that doesn't quite work across the board. So we needed to life cycle hook it so that we can actually just add that one certificate and update the root certificate trusted store, whatever you call it. Yeah.
Awesome.
Great.
I think so you hand over these air gap clusters to your customers, and they are
No, it's actually they have to. So it's funny how 5G telcos work, because most of 5G operators actually don't write any software, right? They use network functions from a whole bunch of different software providers, right? They run the cluster, and the network function software providers actually sell them the network functions, and they run them, right? Which is basically
Right.
the same. Like if you think about it in the context of kind of like non-virtualized or containerized network functions, right? Like no telco would build switches. No telco would build routers. They would go and buy them from some hardware provider.
Right.
The same model, right? So instead of sending them a switch, you send them a network function, and they're running the cluster. So every one of those telcos is going to have, and this is why it also has to be very dynamic, right? Because every one of those telcos is going to have a relatively different setup. They're running their clusters a little bit different. They're deploying them a little bit different, but they provide the cluster, and they say, hey, this is the cluster. There's no internet. We need to install your stuff. And we're saying, all right, we're going to do GitOps. So we're going to give you a platform that you just push into a repo. Because after at that point in time, we're actually building something that other network function providers can also use, right? Because if some network function provider only has a Helm chart to deploy their containers, they can just push it to the same GT, right? And they can just use the same sync process. They can just add an
Yeah,
application.
that would have been my question. So basically the 5G telcos, they push their own workloads on the cluster using GitOps methodology.
Methodology.
I mean, yeah. And they use Argo CD actually for that. So you give them you bootstrap the whole cluster with all the technology on it, and they will use Argo CD for deploying those functions.
That's the idea. Basically, what
Oh.
we build for them is a platform that they can use to do GitOps with the network functions that our clients providing, as well as other network functions or any workloads that they're running. Now they have a registry, just push it to the registry. Now they have a repo, they just sync the repo, and they can do GitOps on top of the platform that we built in their air-gapped cluster.
Awesome. Thank you.
Thank you.
One more quick question. So did you heard any complaints about some features of Argo CD that would not be used in this case, like SSO? And the reason I'm asking is that we kind of thought a lot about building something which more specific for that type of use case, where you run Argo CD inside of a cluster, and that means no multi-tenancy because you don't have tenants, you don't have users. Do you think there is, it's a good use case to create something which is lighter than Argo CD? Like a different way to bundle Argo CD, maybe, which doesn't have UI, doesn't have API server.
That is a good question. I didn't actually run into any such hints. You know what I'm saying? I think, and I would even wonder what, I mean, there's benefits to that. Of course, there's this lesser surface to secure. It's kind of like smaller payloads to bundle. I think there's kind of like likely benefits in terms of lightweightness. But again, I mean, from our specific point of view, since we were actually looking at many different scenarios that we're trying to satisfy with building the platform, we really could not say there is not going to be one scenario where in this air gap environment, maybe the not just cluster, right, but in this air gapped environment, meaning there is a cluster and there's other stuff, there wouldn't be some, I don't know, OpenID identity provider, right? So that would eventually say, all right. Matter of fact, there's not an air gap, but some other clients that are running non-air gap clusters are using Keycloak, right, against an OpenID identity source. Um, I think in terms of manageability, the UI has been very well received. Everybody really loves the visibility that it provides. So I would not take that away, even if it's lightly used. And matter of fact is, for example, in the context of progressive delivery, like when you have rollouts running as well, the integration that you can see in the UI, you know how you can pause and continue and whatever do your rollout, that has also been very well received. That's been very positive.
Thank you. I didn't
Yeah.
realize that someone still can access that UI. I assumed somehow that no one ever going to access it, but it's like,
Which is, from my perspective, a no-no, right? Because I keep telling people, like I think there's, I mean, this is a just personal opinion. I think the UI promotes poor practices. You know what I'm saying? Because people have a tendency to just go in there and mess stuff around. But people are people, and that's what they do. And I'm people. You know what I'm saying? So it's what happens, and I think it's useful.
When it comes to the choices you made here to use Argo CD, to use Argo rollouts, obviously there are a lot of advantages to that over just like having the registry set up and then just doing a kubectl apply instead of doing a git push. In this scenario of the air gap, what were the kind of key things the key benefits that you were thinking about for going this direction?
I think there's some there's some backing history to that question. We did not start with a air gapped environment, and not all clusters are air gapped. And I think one of the major objectives was we've built this platform that is working really well across many different use cases and different clusters and different environments. And now we have this new use case that came up that, interestingly enough, kind of like from a historical perspective, it wasn't expected to be the case. Like when we got into the project, we actually were specifically told, you don't have to worry about air gap, right? But as we moved forward, it turned out that we had to. So it gave us a single code base to manage. It gave us a single process to manage, and eventually, I think it also turned into value for the operators of these clusters, because sometimes they're running not just that one air gap cluster, and they're happy with what they're doing. They're kind of like now publishing their images. Now they have kind of like version control, and they actually do want to keep that sort of workflow happening. It definitely was not the simplest solution, right? But I think overall it gives them a lot of manageability that has resulted in value, perhaps unanticipated, but definitely valuable.
All right. Yeah. Well, thanks again, Leo.
You
that was
bet.
really impressive, the work that you guys done.
Thank you all,
I just-
and look me up, and let's keep the conversation happening. I love
yeah, I think this will benefit a lot of people trying to do the same thing.
Awesome. Thank you.
All right. Next, Alex will give an update on the Argos CD image updater.
Okay. All right. So my name is Alex. I'm a software engineer at Intuit, and I work full-time on Argo CD. So I'm an Argo CD maintainer. And I'm going to talk about a project which is hosted in Argo Rollouts Labs, which is a home for kind of ecosystem projects for all Argo projects. And I'm going to paste link into the chat just now. And I want to give a credit to Jan because he did all the work. I'm just going to talk about the project and I will do a quick demo. Okay, and before I jump into the demo, I just wanted to quickly talk about what problem does it solve. So if you Argo CD user and you obviously know what GitOps flow is, you're supposed to have a deployment repository that has a bunch of YAML files, and those YAML files eventually will have maybe deployment definition that uses a Docker image. So, and if you're making some changes manually, then you benefit a lot from, pull requests, pull review process. But once your manifests are stable, then you still have to keep making very boring changes. You're just bumping the image tag of your image, and that causes annoyance. Kind of developers don't like to make these trivial changes and approve them. So, and especially it's important if you follow continuous deployment methodology and you deploy each and every commit. So you might have to change those manifests multiple times a day. And basically Argo CD image updater tries to solve that problem. So without image updater, this problem is solvable. Still, we often get this question about how the process can be improved. And we keep suggesting to just use CI tool, whatever you use, maybe it's Jenkins or GitHub Actions or Circle CI. As soon as image is built and pushed by your CI pipeline, you can have one more step, and that step simply clone the repository that contains deployment manifests, and then somehow change some files inside of that repository. It's up to you, basically, because only you know what kind of files you have. And then it push the change back, and then Argo CD kind of continue the work. It deploys the changes into the cluster. And since that step is so trivial, why don't we automate it? And this is pretty much what Argo CD Updater is doing. And now I am going to share my screen, and I will just show you the process live. Okay, can you see my screen?
Yes.
Awesome. Okay. And so I don't have a nice presentation, but I have this little script, and I think I can share it afterwards so you can repeat the same process. But yeah, here is the idea. I'm going to deploy a simple application, and then I will perform upgrade of that application using Argo CD image updater. And I'm not going to execute these few steps because these steps are trivial. And basically what I'm doing here, I'm just creating a minikube. Then I'm going to install Argo CD into that minikube cluster. And I'm going to make Argo CD available outside of a cluster. And I'm sure if you ever played with Argo CD, you all did these steps. So we can skip them. And this is my browser, and it has Argo CD user interface. Let me refresh the page to make sure it's still alive. Yeah, so this Argo CD has nothing on it, no applications, and my Minikube cluster is empty. It has nothing except Argo CD. Okay, and next, one little thing we need to do, we need to choose what we're going to deploy. And I propose to just use existing repository. So maybe a lot of you saw that repository. This is Argo CD example apps repo in Argo Approach GitHub org. And it has a bunch of basically the same application, which is deployed using different config management tools. And there is JSONnet, KSONnet, Customize, or Helm. And I'm just going to use Customize. So, and it's basically that repository and that folder inside of that repo has exactly what you expect it to have. It has customization.yaml file, service and deployment. And my deployment uses the famous guestbook application, and it uses version 1. As you might guess, I'm going to upgrade it to version 2. And next, important step, especially if you're going to repeat that exercise, I do not want to use exact same repository. I want to create fork because I want to make changes in it. I want image updater to make changes in that repository. So I created the fork in that repository, and pretty much, yeah, this fork, as you can see, it has same commit, so 0fe, and this guy here, nope, not quite that. Okay, I know why. Basically, I forced pushed and deleted all the commits. So we start from, let me verify the image. I want to make sure it has the same image. Yes, it has same image and still 001 tag. Okay, I think we're ready to do the demo. So finally, we're going into steps which are specific to image updater. And image updater is not yet installed, but we already can do some kind of configuration. So this CLI command, which you hopefully can see, what it does, it configure my fork credentials in my Argo CD. And the reason why I have to do it is because I need, eventually, image updater needs to have write permissions to my fork. And basically, image updater integrates well with Argo CD and is going to reuse credentials. So let me run that step. Oh, never mind. The server is not 8080, it's 443, sorry. Awesome. So my repository is created, and we are ready to create an application that is which uses that fork. So let me go ahead and I want to create that application. I'm using kubectl here, but you can use Argo CD CLI. And before I run that, actually, let me run that command and I will explain what that application looks like. So it is going to deploy resources from my fork into namespace default into the same cluster. And what's important, it uses automated sync policy. So what that means, basically, as soon as application is created, Argo CD is going to make, to push changes into the cluster. And let's quickly verify it. Oops, sorry. So yeah, application was created and it finished syncing just now. And if you're not familiar, this is Argo CD UI, and it's showing us kind of all the resources which were deployed into the cluster. And this little box is a pod which is running already. I can click on it and I can see that there is an image. So that pod uses image guestbook and version is 01. Cool. Finally, all preparations are done. And next, imagine you want to make a new change to your application and you want to deploy a new image. And let's say image is built already and pushed into the Docker registry. So as I mentioned, traditional way is to have something in your Jenkins pipeline that is going to modify the deployment manifest. So instead of doing that, you can repeat the following steps. So step one is to install Argo CD image updater. And the installation is trivial. It's just kubectl apply. If you manage Argo CD using, let's say, customize, you can simply add one more remote base, and that would be it. So, and I'm going to run that command, and that's it. So updater is installed and running. And the good part is that no additional configuration needed. So, but updater is not doing anything yet because we basically didn't ask him to do anything. And the next step is to explain updater that we want to manage some images of some applications in our Argo CD. And to enable automatic image management, I just need to run one more CLI command, which is going to create a couple annotations on our guestbook application. Let me run it. Oops. Specify namespace. Done. So I just put two annotations to my application, and let me quickly walk you through these annotations. So this is the first one. Hopefully you can see it. So it's a Argo CD image updater. Both annotations have the same prefix, and we have kind of two suffixes here. One is image list, and that list contains the list of images that we want to manage automatically. And the second is how we want to manage it. And in this case, I choose to use Git, and I'm going to talk about additional options in like a few minutes. So pretty much this is it. An updater already supposed to notice it, or at least it basically check applications every 2 minutes. Hopefully it noticed that we put annotation already, and I want to just check logs and see if it did it for me already. Not yet. I don't want to make you wait 2 minutes. I'm just going to restart it just to kind of force track and check logs again. Awesome, something happened. So as you can see, updater noticed there was one application which has annotations, and then it's basically, it checked the Docker registry, it found the new image, and eventually it should have been upgraded my application. Let's check. Demo gods might be brutal to me today, but let's see. Oh no, never mind. It's still processing. Hopefully it will finish it successfully. Oh yeah, actually it did. It did make a change. It pushed something to the Git repository. And I think what happened is Argo CD have not noticed the change yet. I just need to click refresh button because Argo CD checks it every few seconds. So when I click refresh, I told to Argo CD, hey, go check my Git repository. And as you can see, something changed. And we can use Argo CD user interface to figure out what was it. And as you can see, new pod was created and it is running a new image 0.2 as expected. So awesome, demo worked. This is a good sign already. and last thing I wanted to show you, I want to show you what exactly an image updater did. If you go to your fork and go to commit history, you will see that a new commit was created just now. And then if you click on that commit, you will see that it was authored by Argo CD image updater, and it created magical file, Argo CD source guestbook. And I think it's important to explain what that file means. So before explaining the content of that file, I want to quickly remind you about existing features of Argo CD that maybe you used already. It's called application parameters. And basically, parameters will give you opportunity to change something in your application without making change in Git. So in this case, in case of customize, you can override image and you can give a different image tag, image name or different tag. And eventually, when you click save, it will be stored in application manifest under the source field of this application spec. So that magic file is nothing but application source stored in a YAML. And this is a new feature of Argo CD 1.9. So basically, now you can modify application source by creating a file which name is .argocd-source-application name.yaml. Yeah, so, and this way, basically what we did in Argo CD 1.9, we, in addition to existing programmatic API that allows you manage applications, you now have API that is a file in Git. and hopefully that makes sense. And basically, Argo CD image updater uses that way to modify your application by making changes in your deployment repository. And now, if we go back to the annotation which I created, which I put to the application. So the method of how you can modify the image of your application. So there is one method is Git, and second, I think it's called CRD, but basically an image updater can manage directly application CRs, and it can modify source of applications, or it can save that source back into the Git. All right, we have 10 minutes and we need to reserve some time for JC. So I think maybe we can spend 2 minutes for questions. Yeah, please let me know if it makes sense at all to you. And if you want to ask anything else, please go ahead.
How the image updater will manage the image credentials from the wherever it is pulling?
Yes, image credentials, you by default, image updater kind of assume no, no password, no username access, it's no authentication access. But if your image repository is requires credentials, you can configure it. Yeah, but if it's just Docker Hub, like in this case, there is no need to configure it. Yeah, and configuration, I kind of encourage you to take a look at image updater documentation, and basically you can just create a secret, and that secret can have credentials to connect to your Docker registry.
Alex, another question is, in the documentation, I was seeing that it is not applicable for standard YAMLs. Is that still holds good?
I'm sorry, for kind of YAMLs?
Not for customize the standard YAML deployment.
Oh yeah, right now, basically, I thought about it and it's not yet supported. And to make it, it's possible, I think we will eventually add support for standard YAMLs, but only way to do it is if we teach Argo CD to customize standard YAMLs, most likely, but by applying maybe merge patch to the whole list of deployment manifests, then image updater can leverage it. But right now, Argo CD don't support it, and so image updater don't support it either. So short answer is yes, it's not yet supported.
Okay, thank you, Alex.
Okay, any other
This
questions
could-
for Alex?
Mm-hmm.
How do you draw a line between Argo projects? Like when I'm looking at this, my head is imagining that this could easily be Argo event as well.
Yes, I think you can automate it using Argo event. But so what we're trying to do here is that image updater knows how to change images in a particular config management tools, because it basically image updater will recognize that that application uses customize, and because it uses customize, it knows exactly what kind of change would be done in the Git repository, and this is the value. So even if you use Helm, you will have to add a couple more annotations, but basically you can just explain to image updater that, hey, this particular Helm parameter is image tag, and it will, and as a result of it, you will have to script less. And most likely image updater will be a little more stable than a custom script, because it's kind of narrow in scope. It's not supposed to, it won't let you run scripts every time when new image is pushed. Instead, it knows exactly how to change your application source to use the new image.
Yeah, no, I was more curious, kind of why, not as a complaint, but kind of more a line of thinking. Why didn't you create like event source and trigger?
Why didn't we do that? I think, I mean, this is more question to Jan. Sorry. So the question is about implementation. Why didn't we leverage?
Yeah, kind of like it's more a curiosity question, not. I'm not trying to drill anybody.
Yeah, I think at the time we started the image updater, it was clear that it's very domain-specific tooling, right? So Argo Events is more like a general event processing engine, and yeah, basically it was born out of curiosity, and I think it won't stay a unique project for long. So either we integrate it directly into Argo CD one day, or yeah, so with hooks to Argo events maybe, because what's not currently there is external events from the registry, right? So we don't have any webhook support or something like that. We're plainly polling registries right now. So,
I think
but it's on the roadmap to integrate some event-based processing as well. And I agree that basically would be a very fun use case for Argo events.
Yeah, one more thing is I think it basically makes adoption easier. If you would use events, we would have to ask people to install events in addition to image updater, and we kind of make effort to make image updater almost like a continuation of Argo CD. And I think main reason why it's separated is because not everyone likes that workflow. Like some people like it, some not, and it's an advantage that we can kind of optionally install it in a very simple way.
So if I have to revert the image for any reason, how do I handle that scenario?
I think you would have to kind of stop automatic management. You would have to revert that annotation, remove the annotation, and then manually revert commit. So it's basically, at least as of now, it's like an assumption you would want to use that workflow if you're really using like 100% GitOps. You use automatic automatic syncing, and when you push an image, you're 100% sure you tested it before. This is the kind of use case that it's trying to solve. So CI approach also is automated, but you have way more control because you can run tests before and after, and you can revert in that same CI. Image updater is when you don't need it and you want to keep moving forward. And then if you ever have to roll back, most likely you're going to revert code change. That revert will make a new image and it will push a new image with the fix.
Okay, since we only have a few minutes left, I think I really only need a few minutes for the update on Argo rollouts. But so the next release of Argo rollouts will be called 1.0. And 1.0, I mean, personally for me, that generally means like the product is suitable for production use, one. And we have been using internally into Argo rollouts for in production for probably over a year. And two, we don't anticipate any, breaking changes in either the experience or in the APIs. And then three, we feel that the critical features that that we set out to do with the project, we considered that complete. Of course, there's always going to be future enhancements, as you'll see in this document, but for the most part, we accomplished what we set out to do with the project. Okay, so what's going to be in the 1.0 different from 0.10, which is the current release? So 0.10 was focused a lot on stability, and so there's a lot of kind of usability, minor issues that were a lot of these things were fixed in 0.10. Some other things we discovered was, so this first issue called weight verification. If you ever use rollouts with ALBs, if you're an Amazon shop, you know that in AWS you're affected by things like rate limiting, and so one thing we discovered that was when using the ALB, it takes some time for a set weight change to take effect in AWS. And that's actually quite dangerous if you if rollout doesn't know that its set weight changes are not taking effect. It's going to keep progressing through the steps, unbeknownst to that it's not actually changing the weights underlyingly. So 1.0 will introduce a new flag in the controller that actually allows the rollout controller to talk to AWS to look at the target groups and confirm that the weights are what it expects. And it will stop the update. It won't progress the update until it performs that verification. That's been implemented in a generic way, such that if there are other providers like Istio or something that also can do some form of verification, they can also implement that if for those other providers. The second thing coming in 1.0 is another way to do Istio canarying. So I'll show you the first way, which is host level traffic splitting. If you're familiar with Istio, you know that in order to achieve traffic splitting, you want to split weights through multiple HTTP destination routes. And one of the ways is actually to specify different hosts. So in this case, host is going to the stable service, and then host is also some of it's going to the canary service. There's actually another way you can do traffic splitting in Istio, which is actually using something called destination rule subsets. So, and then this is the other way. So I have the same virtual service. This time the hosts are the same. So host is going to this service called rollout example, but it's splitting instead on Istio destination rule subsets. And so, and then you have this destination rule, which has two subsets, a canary and a stable. And what the rollout controller will do in 1.0 is that it will be able to modify this destination rule such that the canary will be pointing to the replica sets containing the pod template hash value of the canary, and then the stable with the stable. This is a typo. So it just provides a different way of performing Istio canaries. There are trade-offs to both approach, which I describe in this document. I won't get deep into it, but it turns out there's a good use case for using destination to do intra-cluster canarying, basically microservice to microservice canarying. Okay, so those are the kind of the two big features in 1.0, and then coming later in no particular order is that now that Argo CD notifications has been split into a generic notification engine, we actually want to leverage that same experience for rollouts. Namely, we would like people to annotate a rollout in order to get events or notifications, I should say, about that, like Slack notifications. And so the experience that we want for rollouts with notification support will be exactly the same as when you want notification support on application in Argo CD. So that's planned for the next release. Lastly, and I won't go into this all of it, though, questions that we commonly get with rollouts is a rollout currently inlines the pod template spec, and it combines that with like a new section for strategy. So we've always described rollout as a drop-in replacement for a deployment. So Alex actually gave a good idea of like why have to inline the pod template in the spec, and why not just reference something like a deployment? This actually is a similar approach to what Flagger does. So the idea is that instead of inlining the whole pod template inside the same rollout, what if we could reference something like a deployment, or there's actually in Kubernetes, there's actually a resource kind called pod template, which is just like a pod spec in a CR and a resource definition. And if we do that, we are able to split out the definition of what run from the strategy of how to perform updates. And this, the idea behind this is it would make people who are migrating from a deployment to a rollout much easier. Basically, they can leave their deployment in as is, drop in a rollout, and reference that deployment, and then this would rollouts would still create replica sets, and the expectation is that the deployment should be scaled down to 0, but it's simply using the deployment as a definition, and so you're not inlining the definition inside the rollout spec. All right, so you can read more about what we have planned in this roadmap, which is not in master right now. It's in my personal branch, but this is kind of what we've gotten requests to add more support for other ingresses or meshes. Ambassador, there is a request, and then another one that we got in the chat was Citrix Ingress Controller is another one. So those will be community contributed, but those are also something to look forward to in future releases. All right, so we're out of time. So I think I can answer your questions in Slack, but I don't want to keep people in the meeting. Well, thanks everyone for attending the February Argo Rollouts and CD meeting. And we'll see you in 2 weeks for the workflows and events meeting.
Thank you.
Thanks, everyone.
Thank you.
Thank you,
Bye-bye.
Jesse. Bye.
Thanks. Bye.